Getting ready for your WAEC Chemistry exam? Well, you have come to the perfect place. Today, we are going to unlock the one topic that is the key to pretty much everything else you'll study. And I mean everything. From how your phone stores energy to why sugar just seems to disappear in your tea, we're talking about the atom. And trust me, by the end of this, it's going to be your chemistry superpower.
Now really, just think about it for a second. That energy getting packed into your phone, that's all chemistry. Salt vanishing into water, that's chemistry too. It's not some kind of magic, right? It's science. And it all comes down to the behavior of one tiny, invisible thing.
And yeah, that's it, the atom. It is the main character, the superstar of the entire story of chemistry. The air you're breathing, the food you ate this morning, your phone, it all comes back to the atom. So if you can understand this, you can unlock everything else. Let's dive in.
So here's our game plan for today. We're going to start with the big picture, then we'll zoom right in to meet the atoms family. After that, we'll figure out how to identify each atom, see where the electrons live, learn the rules of their house, and then we'll finish up with the most important points that'll power you up for your exam. Let's get started.
All right, first up, the world inside everything. We've got to understand what this basic particle actually is before we can dig any deeper.
Okay, so this right here, this is your official WAEC definition, so you might want to remember this one. But think of it like this. Imagine you have a big box of Lego. An atom is like one single Lego brick. You can use that brick to build anything, right? A car, a house, you name it. In the exact same way, atoms are the building blocks for every single thing around us. They are the smallest little piece of an element, like gold or oxygen, that can get involved in a chemical reaction.
Now that we know what an atom is, let's zoom in even closer. What's actually inside this building block? It's time to meet the atoms family. So inside every atom, you've got this little family of three smaller or subatomic particles. We have the positive protons, the neutral neutrons, and the negative electrons. Now the protons and neutrons, they all hang out together, right in the middle, in this dense little core called the nucleus. You can think of it like the atom's VIP section. Now, check this out, because this table is super important. Let's look at the charges. Proton is +1, electron is -1, and the neutron, well, it's neutral, zero charge. Now look at the mass. Protons and neutrons each have a relative mass of about 1. But get this, look at the electron. It's tiny. Its mass is so small it's almost nothing, about 1/1840 times smaller than a proton. That means that pretty much all the weight of the atom is packed right into that VIP center, the nucleus. Think of it this way. Just like you have an ID card that says who you are, every single atom has two special numbers that give it its own unique identity. This is how we tell one from another.
Okay, listen up, because this is maybe the most important number in all of chemistry. Seriously, the atomic number, which we call Z, is just the number of protons. That's it. If an atom has 6 protons, it is carbon, full stop. If it has 8 protons, it's oxygen, always. This number is the element's identity. It's its fingerprint, non-negotiable.
And then we have the mass number, or A. This one's pretty straightforward. It's just the total count of the heavy guys, the protons and the neutrons, all bundled together in the nucleus. It basically tells us how much that VIP center weighs. Simple as that.
And here's where this becomes super useful for your exam. If you ever need to figure out how many neutrons are in an atom, it's just simple math. You take the mass number, A, which is protons plus neutrons, and you just subtract the atomic number, Z, which is just the protons. And what are you left with? Just the neutrons. This is an easy mark, so don't miss it.
Okay, so we've spent a lot of time in the atom's center, the nucleus. But honestly, all the action, all the exciting stuff in chemistry, the reactions, the bonding, the electricity in your phone battery, that's all about the electrons. So let's find out where they live.
Electrons aren't just buzzing around all over the place. They live in specific energy levels called shells, kind of like different floors in a tall building. The first shell, the one closest to the nucleus, is called the K shell, and it could only hold 2 electrons, max. The next floor up is the L shell, which can hold 8. Then the M shell can hold up to 18. And the most important rule, electrons are lazy. They always fill up the lowest energy shell first, so they fill K before they even think about moving to L.
Now, if we zoom in even closer on these shells, or floors, there are even smaller sublevels, like specific rooms. We call these orbitals. Now, why do we care about these rooms? Well, knowing about orbitals helps us understand the exact shapes of molecules and predict exactly how they're going to react with each other. For WAEC, you'll need to know about the s, p, and d orbitals, and the rules for how electrons fill up these rooms.
So,
Just like any house has rules, the electron house does too. There are 3 main rules you absolutely have to know to figure out where all the electrons go. Get these down, and you can predict how any element will behave.
Here they are, the big 3 rules. First, the off-bow principle. It just means build up. You fill the lowest energy orbitals first, starting from the ground floor. Second is Hund's rule, and I love this one. It's the bus seat rule. When you get on a bus, you take an empty seat first before you sit next to someone, right? Electrons do the same thing. They fill up each orbital in a sublevel with 1 electron before they start pairing up. Finally, there's the Pauli exclusion principle. This just says that if 2 electrons do have to share a room or an orbital, they have to be opposites. They must have opposite spins.
All right, fantastic job. We have covered a lot. Now it's time to bring it all home. Let's consolidate everything into your final power-up points. This is the stuff you absolutely have to lock in for WAEC.
First things first, let's clear up a really common mix-up, the difference between an atom and an ion. A regular, neutral atom has perfect balance. The number of positive protons is exactly equal to the number of negative electrons, so the total charge is 0. An ion, on the other hand, is just an atom that has either lost or gained an electron. So now the balance is gone, and it has an overall positive or negative charge.
And here it is, your final checklist for success. Number 1, the proton number is everything. It defines the element. 2, the mass number is just protons plus neutrons. 3, in a neutral atom, protons and electrons are equal. 4, the electrons are the ones that do all the work in chemical reactions. And number 5, make sure you can write out the electron configuration for the first 20 elements on the periodic table. If you can master these 5 points, you are in great shape.
And you know, I want you to remember this. This isn't just about memorizing facts for an exam. When you really understand the atom, you're starting to understand the basic code that builds everything around us, from the stars in the galaxy to the screen you're watching this on right now. It's a pretty powerful idea.
So I'll leave you with this thought. We started by asking about a phone battery. Now you know the answer has to do with tiny electrons moving between atoms. You have the fundamental building blocks. So the question isn't just, how does it work anymore? The question is, what can you understand or maybe even build one day with this knowledge? Keep asking questions, keep being curious, and go ace that exam. Good luck.